All right, calculus class, this is lesson 26. Couple of things. I cannot show you this with a graphing calculator, so I'm just going to give you, these are a couple things that you need to memorize. The first one is that the derivative of e to the x is just itself. The derivative is e to the x. That's the first one you need to memorize. And then secondly, the derivative of natural log of the absolute value of x is equal to 1 over x. And those are two concepts that you need to memorize. Now, we're going to take this and apply it to the examples. I'm going to go over examples 1 through 4 with you. Example number 5 I'll probably do in class and give you the rest of the time for homework. If you look at example number 1, 26.1, we have y is equal to 4 times natural log of x minus 6e to the x plus 2x squared. Okay, what we would do here is you have, okay, they ask us to find the derivative of dy dx. All right, now 4 is just being multiplied by the natural log of x. We've already found out the natural log of the absolute value of x is just 1 over x, so the derivative of the natural log of x would just be 1 over x. Okay, and I said that the derivative of e to the x is just e to the x. We have the 6 in front of it, so it'd just be 6 times e to the x. All right, now from the previous lesson, derivative of 2x squared, what you would do is take the exponent, multiply it by the coefficient, which is 4, subtract 1 from the exponent, which is 1, and you get 4x. And now we just clean it up a little bit. So the derivative would equal 4 over x minus 6e to the x plus 4x. Okay, example number 2 is just the same. Looking at example number 3. All right, finding the derivatives of sine and cosine. Now, if we were to graph sine, all right, we know that sine y equals sine x. The graph of it looks like this. It goes up to 1, down to -1 when there's an amplitude of 1 out in front of it. Remember that at 180 degrees, or if you divide this into 4 pi over 2, or 45 degrees, then you have pi, and you have 3 pi over 2, and then you have 2 pi. Or remember in degrees, this is 45, this is 90, 180, 270, and 360. So we graph this sine would go through the origin down here like this. Now, remember when we're talking about derivatives, we're finding slope, finding the slope of the line tangent to the curve. All right, so if we look at this, we can find some things with sine. We know that right here at the top of the hill, the slope would be 0. We also know that the slope at the bottom of the hill here would also be 0. All right, other things that we know about this is that the slope here would be going up, that would be positive, whereas the slope here is going down, it would be negative. Okay, the same thing here. Slope here would be negative, and then going back up from left to right would be positive. So if I make a sketch of this, okay, if the derivative is 0, okay, the derivative is 0 here, we're going to go ahead and graph that. That would mean at 0, if we drew a line straight down, that it would be equivalent to 0. Okay, the derivative of the slope is 0, so we would intersect the x-axis. Also, we have a slope here that's 0, so it would go right there. And now we've also found that the slope is positive Okay, the slope is positive, meaning that it would have to be above the axis here. Okay, and we see the slope after this is negative, so it dips below. So this whole part would be negative all the way to 0. So that means it would be below the curve. And then we see when it gets here, it would go above the curve. I didn't draw it quite proportionally right. But if you look at this, if we would extend this, the derivative of cosine actually just gives us the graph of cosine. Okay, so we could say that the derivative of sine x is equal to cosine x. Okay, now we're going to look at the slope of the graph of cosine. Okay, we see here, it's at the top of the graph, okay, you would have no slope. Okay, so the slope is equal to 0 here. Okay, so if we were to graph the derivative function, the derivative here would be equals 0, or be right on the x-axis. Okay, talking about derivative, talking about a slope. If we look here at pi over 2, we can see that it's going from left to right, that the graph is going down. Okay, and if we were to examine more closely, if I graphed it more accurate, okay, the slope is actually -1 there, okay, or equal to -1, all right, which would be down here. Okay, going down means it would fall below, okay, below our x-axis. For it to be negative, it would be down here at -1. Okay. All right, we look at it at the graph. Next, it would be also equal to 0 at pi. So we go to pi, try to go directly underneath it to that graph it accurately. Okay, at pi it would be equal to 0. We then go to 3 pi over 2, we see now that the graph, or the slope of the graph, is going up. So it's going to be equivalent to +1. Okay, then finally back at 2 pi, we see that the slope peaks at the top. And so the slope here would be equal to 0. And we'll plot that point. Okay, now, if I complete my graph, it would include all the points in between. We look and we're going to recognize that this is also a trig function. Now, it goes through the origin, so the derivative of cosine we know is going to be equal to sine but if we look at the graph, it's going down through the origin. So it's actually going to be equivalent to negative sine x. So now we have two new derivatives. The derivative of sine x is cosine x, and the derivative of cosine is negative sine x. We're going to use that for example number 3 and 4 to solve those. Okay, now we introduced that the derivative of e to x is just e to x, and the derivative of natural log of x is 1 over x. And then I showed how we get the derivative of sine x is equivalent to cosine x, and the derivative of cosine x is equal to negative sine x. Now we're going to use that in example number 3 and 4 to solve the problems. Okay. I'll look at example number 3. And we have y is equal to 3 sine x minus cosine x plus 2e to the x. And example number 4, we have y is equal to negative 3 cosine x plus 3 ln of x minus 2 sine x. Okay. Now we're going to take the derivative, or the change in y or the change in x. Remember, talking about derivative is slope. So we'll write in this notation. Okay, remember, it can be written as this. Anytime you have d, in front of it, it's going to ask us for a derivative. All right, so we do the derivative of 3 times the sine of x. All right, well, 3, that constant out in front is just going to stay the same. Derivative of sine x, we've said, is cosine of x. Okay, now, we have the derivative of negative cosine x. Since the derivative of positive cosine x was negative sine x, okay, what we have here is we would just keep our negative, and then the derivative of cosine would be negative sine x. So this is going to then be plus sine x, which will change in just a second. Then we got plus 2 times it by the derivative of e to x would just be e to the x would be 2e to the x. And the only thing we need to do then is change it to 3 cosine x plus sine x plus 2 times e to the x. All right, then we look at our last example. Okay, taking the derivative of this. Here we have the derivative of negative 3 cosine x. Well, negative 3 out front, the constant just stays there. We take the derivative of cosine of x. We know that's negative sine x. We have plus 3. Derivative of natural log is just 1 over x. And then minus 2 times the derivative of sine x, which we know is cosine x. Or that over there. All right, so then we're just going to simplify this. 2 negatives is going to make it positive, so this would be 3 sine x plus 3 over x minus 2 times cosine of x. And there we have lesson 26.